Welcome, mathematicians. This will be your first video for Geometry Accelerated. It's going to be 1.1, so properties of real numbers, and we're going to start off a little slow and just kind of build from there, right? So we're going to start with some of the things that kind of makes a number system, right? So for example, if you want to go ahead and pause, this would be a great place to pause and write stuff down so you can listen to them later. Um, but this is going to be, we're going to start with an additive inverse, right? So if you think about it, an additive inverse is something that when we add it together, it makes us our identity, right? So there's all those words in here. So an additive inverse of any number a, so a is a variable, is negative a. It's an opposite, right? Sometimes called an opposite. The sum of the opposite is zero, right? Which is known as the additive identity, right? So those two things are the same. The multiplicative inverse of any non-zero a is 1 over a, right? So this, we might have seen that before, and we might have called it something like a flip, right? We call these relationship between these numbers reciprocals. The product of these reciprocals is 1, right? So again, if we're multiplying them together, so like it's a multiplicative inverse. So when multiplying the a times 1 over a, we should get 1, right? So that's the difference between those two identities, additive and multiplicative. The absolute value of a real number is the distance from 0 on the number line. Okay, so again, if you don't remember, then we'll go over it in just a little bit. Next, we have some of the sets of real numbers, right? So a set of real numbers, we could think about how we organize them together. So we have what we start with in kind of kindergarten or preschool, right? And there's natural numbers, 1, 2, 3, 4. And then whole numbers is usually considered with 0, right? Is when we start to consider 0. Integers is when we start to get a little bit more advanced. We consider the negative numbers, right? So now we can start talking about having additive inverses, and additive identities. And then finally, the rationals. Oh, not finally. Sorry. Then we have the rationals, which are fractions or things with a repeating decimal. So here are your fractions right here, and then you have repeating decimals over here, right? You can also have terminating decimals, so decimals that end. That is also considered a rational, right? Anything else is called irrational, right? So we have all these other things over here, right? So pi, any of the radicals or square roots, decimals that don't repeat, right? Those are irrational numbers. And those altogether will be the real numbers, right? So if I could put a big box around these are all real numbers, right? So these right here should have a box, and those are just generally called real numbers, right? If you just put it all together, these are going to be my real numbers. So again, just to repeat those things, you could test yourself. Again, pause right here if you need to. If not, you can just go back, rewrite this. Okay. So again, natural numbers, whole numbers, integers, rational numbers, and irrational numbers. Those are just the formal definitions. So now here's a good spot to kind of test yourself, right? Do you actually understand what these things mean? And as we go through these notes, it makes sense to pause and to think about these things instead of just trying to get it done, right? Give yourself a few moments and think about which of these like types of numbers where they fit, right? Or we're classifying them, right? So the number of participants in a race, right? Think about it. Can I have negative participants? No, that doesn't make any sense. So if you think about it, take your guess and reveal, right? Um, so those are whole numbers, right? So the donations for one participant, right? Think about that for a moment. Rational numbers, right? So it's a decimal that's going to be terminating. You can't have 0.00173 of a donation, right? It's a decimal. It's like a cent, right? It's a terminating decimal. Next one is the total amount of money raised, right? Total amount of money raised. Think about it for a moment. Again, if you have to pause, that's what pause. So those are called rational numbers, right? It's going to be like it could be a decimal, right? It's not going to be a non-terminating decimal, right? Yeah. This one's a little bit more challenging, right? So again, give yourself a moment. So this one is rational numbers as well, right? The average running time of participants. So you could think about it as what an average is, right? So this is a little bit tricky because what is an average? It's the number divided by the total or possible, right? So that's a fraction, right? So you already know it can be written as a fraction, which means it falls under the group of rational numbers. So this one is just to help you kind of recall where some of these things are on the number line, right? I will go through the first couple of them, and then what I want you to do is try the next one again, pause, and then we'll go through it. Um, so square root of 5, you might not know what the square root of 5 is, right? But you could use your calculator here, or you can use your calculator on your computer and figure out what it is as a decimal, right? So I'm going to put in square root of 5. And as a decimal, it's actually 2.24 about, right? So I'm going to put my point in between 2 and 3, right? Closer to 2, but in between 2 and 3, right? Um, Next, the negative 1.4, right? So that should be a little bit past negative 1, right? So it might be easier to see. So again, this is negative 1, so negative 1.4 should be just a little bit past. And this is a repeating decimal, right? So it's negative 1.444444. And then lastly, 1/3, right? Again, you might not know where 1/3 lands, right? So if you're unsure, that's a good place to check, right? 1 divided by 3, 0.3333333, right? Repeating, right? So that is in between, or another way to look at it is like 33 cents, right? It's about 33 cents. It should be between 0 and 1, right? So we're going to put our point right there. Um, Next we have and again, try it on your own. If you're feeling good, um, maybe you don't have to listen to this part. But I'm going to go through it really quickly so that we can kind of move on. Again, radical 17, I don't know what that is, right? So I'll put it into my calculator. Or you can take a better idea, might be to take a guess at it, right? It's a little bit more than 16, right? And 16 is going to be 4, so it should be a little bit more than 4, right? Negative 4.6, again, that's pretty easy to just go down to negative 4 and just go a little bit past that. It's between 4, it's like, $4.60. So it's between 4 and negative 4 and negative 5. And the last one is just a little bit more than 2. So then that one fits a little bit more than 2. So again, this one might be a little bit challenging, but try it out on your own, right? And I'll give you a moment to pause and to try to think about some of these things because they are kind of tricky, right? Because we've mentioned them before, but we might not have done them yet. So this is negative. I'm going to start with negative absolute value of 4. So if you think about it, this is the distance. And another way to think about it is if it's negative, we just make it positive because there's distance is weird to think about negative distance in most cases, right? So we're going to say this is the absolute value of negative 4 is just positive 4, which is why our dot's right here. The next one, 12 over 5. Again, if you're struggling, put it into your calculator. It's in between, it's 2.4, so it's in between 2 and 3. So find out right there. And then lastly, negative pi. So if you're unsure again, calculator, it's pi is 3.14 about. So it's going to be just a little bit past negative 3. This is negative pi. Put my dot. Another skill that we need is ordering real numbers, right? So we want to make sure that we know like these things can be written as different in different ways. And we want to see which one is larger sometimes or if they're equal sometimes, that kind of thing. So square root of 26, that's going to be a little bit larger than 5, right? Just a little bit. So then I can tell that this side is going to be larger. So this is going to be, and then you can remember that the alligator eats the bigger number, right? So this is going to be radical 26 is less than 6.25, right? This is how we read that. Next, we have a another set of decimals, right? These could be terminating. They could or not actually they're not terminating. It looks like one of them is repeating, but it doesn't necessarily mean that's true. But from what we can see, I can look at a certain spot. So they both start with a 0.2 equal there so far, right? And then I go to the next term. This one's a 2, this one's a 3. So this one is going to be slightly greater. So we're going to say this is, again, less than is what we say, right? Uh, Next, we have kind of a tricky one. So again, I would use my calculator in this. I might not know offhand. There's a couple tricks we can do. This square root actually reduces both of those, so then I should get 2 over 3. And it happens to be that that is 0.66666. So these are actually equal. So if you don't know, again, use your calculator, use your tools that you have. These are actually equal, even though they don't look. This guy, we got to be a little bit careful, right? Because these are both negative. So if you think about it, the bigger number is less negative. That makes sense. Um, so then which one of these two is less negative? Actually, it's this guy. This guy is less negative, right? So the way we read that is we say that negative the square root of 0.09 is greater than negative square root of 0.1. Okay? Because again, it's less negative. Closer to 0. How about that? The next one's kind of tricky, but because we have a terminating decimal, if you look at pi, this is about 3.141592654, right? This guy actually has more stuff, right? So because it has more stuff, then we're going to say that pi is greater than, again, you could put greater than if you want to, but pi is greater than 3.1415, right? This one's a little bit tricky. Give yourself a moment. Think about it, right? Um, let A, B, and C be real numbers, right? A is smaller than B, and B is smaller than C. How do you how does A and C compare? How do A and C compare? Explain, right? Well, A is great or less than C because A lies on the left side of C. So think about it this way, right? If A is less than B and B is less than C, then we can simplify that and it should look like this guy, right? Or you could give yourself numbers, right? Give yourself some numbers that make sense to you, right? And fill it in, and you'll see that that is true. Okay. All right. Give yourself a moment. Pause again. Write some of this stuff down, and I'll explain it in a moment. All right. So, uh, closure, in addition, means that basically if you start with a plus b and a and b are real numbers, that it's still a real number in the end, right? Same thing's true with multiplication. If I multiply two real numbers, I still end up with a real number. Yeah, it's pretty easy, right? Commutative property, a plus b is equal to b plus a, right? So again, you can take two numbers, and if I add them this way, it's the same thing as if I add them the other way. Same thing with multiplication. If I multiply two numbers, 2 times 3 is the same thing as 3 times 2. So those things are what we call commutative, right? Associative property is a little bit trickier, right? Associative property means that we can add two things first and then add a third thing after, and it's the same thing as if we add them in a different order, right? So b plus c is equal to a plus b, then plus c is equal to a plus b. I said that wrong again. One more time. A plus b plus c is the same thing as b plus c plus a. And then same thing can be said about commutative property. It just doesn't matter which order that you actually multiply them in, right? Again, the identitive property, right? So identity is a really important concept. We have a plus 0 equals a and 0 equals a. Yeah. Either way, right? If you add 0 to a, you get a again, right? That's for adding, right? And then for multiplying, we're going to multiply by 1. Same idea, though, right? And here's where it gets interesting, is we start talking about inverses now. Because this top part is true, now we can start talking about inverses. When I add a plus negative a, I get a 0. And when I multiply a times 1 over a, I get a 1, right? Again, the ones match here, and the zeros match here. And then finally, the distributive property. Actually very interesting to prove, right? But when you multiply a times the quantity of b plus c, then you get ab plus ac, right? And it's this property is actually associative. Oh, you can do something from above. Yeah. If you didn't see it already, now's a great time to test yourself, right? Look at that first one and think about whether it is which property it uses, right? Give you a few seconds here. It's actually associative property addition, right? Next one, give yourself a few moments. It's distributive property, maybe, yeah. So again, if you forgot, we're gonna multiply those two guys, and it's gonna give us this guy, right? Last but not least, give yourself a few moments. This one's a little bit tricky. What's changing? It's that guy. So which one is that? Multiplication. Who's identity, property, and multiplication. So it's very important to think about these guys in terms of like what's the similarities and differences between addition and multiplication, right? So if we look at like the number 24, right? Opposite usually refers to the additive reciprocal, right? So in this case, it's negative 24, right? Multiplying is we talk about multiplicative reciprocal is 1 over 24, right? So we kind of like flipped it, right? So opposite's easy. Again, we just make a negative. This one might be a little bit tricky in the sense that what is this guy equal to? Well, if you remember how to turn a mixed number into an improper fraction, you multiply those two, you get 15. And then you add 2. So then you get 17. So this is equal to 17 over 3, right? I'm ignoring the negative for a moment. And then, so the reciprocal, I just have to switch places with the numerator and the denominator. Again, opposite, reciprocal, right? This guy again, if you forgot, you just have to read it, right? So this is 1/100th. Make that top part negative So again, if I'm taking the reciprocal, all I'm doing is I'm taking this and flipping it around. Doesn't matter where you put that negative. And that guy is equal to negative 100. This one's a little bit more tricky. We have 1 over the square root of 2. Usually we don't leave it like that. If you don't remember, we don't like radicals on the bottom. It's not a huge deal, but if you multiply by radical 2 over radical 2, this part simplifies, and the denominator simplifies, and you end up with just a 2. Okay, time to practice if you haven't done so already. Again, absolute value of 9.2, you just make it positive. It's already positive, no problem. 9.2, right? This one is a little bit trickier. You have to turn the negative 2.3 into a positive 2.3. So we're going to make because that's what the absolute value does. You multiply those two things together, and you get negative 0.92, right? So this one you kind of treat like a set of parentheses. So what I'm going to do is subtract first, so that's negative 5. And then the absolute value gives us positive 5. Again, treat them like parentheses, right? So this is just equal to 7 minus, again, make that positive, so 12. This one actually ends up being negative, right? And so it really depends on where that absolute value hits. Thanks for watching. I'll catch you at the next video.